Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called FOMO in the Fog by Samu Piano and Sudoku. And here are the rules. We have normal Sudoku rules apply. That is, each row, column, and 3x3 region has to contain the digits from 1 to 9 once each. We also have dynamic fog, where the grid is covered in fog. Correctly placing a digit will clear any fog in its own cell and potentially clear fog in other cells too. No guessing is required. I do like this type of dynamic fog. I don't like the dynamic fog where it doesn't clear its own cell, but this one does will clear any fog in its own cell if you place it correctly. And we also have FOMO cages, where digits in a cage do not repeat and sum to the total in the top left corner of the cage, which is derived by possibly omitting digits and reading the remaining total left to right. Any digit which is omitted from the total must appear in the cage. Oh, okay, that's interesting. It is allowed that no digits are omitted, and the clue simply indicates the cage's total. The cage's total is always indicated in the string of digits. For example, a cage with 1, 2, 3, so imagine this were 1, 2, 3 in the top corner, may be a 12 cage, including a 3, a 13 cage, including a 2, a 23 cage, including a 1, or a 3 cage, including a 1 and a 2. Interesting. Okay, so... Or you could have 1, 2, 3, 4, and again, you just omit digits. So obviously it can't be 124 or 1,234. But it could be something along the lines, for this 1, 2, 3, 4 cage, you could be omitting a 3 and a 4, or sorry, you omit a 3 or 4 from the sum, and therefore the cage total would have to have 3 or 4 adding up to 12. Or you could be omitting 2 or 4 from the sum, and then you would add up to 13 with the 2 or 4 being in the cage. Or you could omit 1 and 4 from the sum number, and then you would have to have a 1 and 4 in the cage adding up to 23 with 2 other digits. So that's an example of how FOMO cages work. So they kind of work kind of like killer Sudoku cages because there are no repeats, but the sum is the thing that's in question here. And it's called FOMO in the fog for that reason. Anyways, if you like to play, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So this must add up to 24, 26, or 28. Because specifically, you can't have 4 digits adding up to 40 something. And you can't have 4 digits also add up to a single digit, right? So you can't exclude all of them. You can't exclude 3 of them. Obviously, you can't exclude all of them, but you have to exclude 2 specifically, because you can't have 200, obviously. So, and the 2 always has to be 24, 26, or 28. If you have 28, you're excluding 4 and 6 from the sum number, but you must include it in the cage. 28 minus 4 and 6 would be 18, and that's not possible, so it cannot be 28. Therefore, this adds up to either 24 or 26. We're not sure which. So the 8 always has to be in this cage because it's always excluded. If we have 26, we are missing 4 and 8 from the sum, so we have to add 4 and 8 in the cage. 4 and 8 in the cage would be 12. 26 minus 12. 26 minus 12 is 14. The only possible combinations of 14 for 2 digits is 5, 9, or 6, 8. But we already have an 8 included, so it can't be 6, 8. So it would be 4, 8, 5, 9 in that scenario. If you had 24, you would have to have a 6 and an 8. Okay, so for the example of 26, you have to have a 4 and an 8, so that's 12, and the rest must add up to 14. So it must be 4, 8, 5, 9, if that's the case. If you have 24, you're omitting 6 and 8, but those must be in the cage. So then you have 6, 8, which is 14. So 24 minus 14 is 10. So you have either 1, 9 or 3, 7. So those are the possibilities. And we know 8 has to be one of these. We have to have it with the 6. Oof. Okay, that's pretty broad. But it's actually fairly limiting. Okay, let's look at these. This cannot be 35. It can't be, these 3 digits cannot ever add up to 1, 3, and 5 by themselves. It cannot be 35, so it must always have a 1 here. So it's either 3 digits adding up to 13 or 3 digits adding up to 15. Okay. This has to have 1 or 2 as the first digit. It could be 12, but if we have 12, we have to have a 3 and a 4 in the cage. And the problem is, if you have 3 and 4 in the cage, you need 2 other digits adding up to 5. Well, that would be either 1, 4 or 2, 3. And we already have the 3 and a 4 accounted for. So this cannot be 12. It could be 13 or 14 or 23 or 24. If we had 24, that would mean we would have to have... Okay, what happens if we have 13 or 14 here? We know this is 13 or 15. If you have 13 and 15, okay, so 8 can never be here. There's no limits, actually, because it doesn't seem like... So let's continue. So it cannot be 12. If we have 13... let's try 24. If we have 24 as a sum, and again, you can't have 1, 2, and 3... 1, 2, 3, 4 by itself to add up with 4 unique digits adding up to it, because that adds up to 10 at minimum for 4 digits. So, say you had... 24 here. That would mean 1 and 3 are the digits that have to be in the cage. 24 minus 4 is 20 for 2 unique digits, so that does not work. If you have 23, that would also mean you have 1 and 4 in the cage. 1 and 4 add up to 5. 23 minus 5 is 18, and 2 unique digits can never add up to 18. So therefore, 20 is out. We have to have 1 in this cage. So we're omitting 2. So 2 has to be in this cage. If you have 2 digits adding up to 13, 4 digits adding up to 13, you have to have 2 and 4. So that would require 2, 4, 1, 6, if that's the case, to add up to 13. Because you have to have 2 and 4. The other digits, 13 minus 6 is 7. It's either 1, 6, 2, 5, or 3, 4, but we already have a 2 and a 4 accounted for. So this would be 2, 4 with 1, 6. If it's 14, you have to have 2 and 3 in the cage. So 2 and 3 in the cage. 14 minus 2 and 3 is 5, so that's 9. So you would have to have 1, 8 or 3 and 6 along with the 4. No. It would be 4, 5 as a possibility. So this is 6. This could be 4, 5. So we always have a guaranteed 2 here. It's either 1, 2, 4, 6 adding up to 13, or it's 1, 2, 3, 8 adding up to 14, or it's 2, 3, 4, 5 adding up to 14. Okay. These 3 digits add up to, if it's 15, you subtract you have the 3 there. So if it's 15, you have 3, therefore the other 2 must add up to, this can never be 8 or 2. So this is 1, 3, 4, 5, 6, 7, 9. 8 cannot be here. If it's 15, you have a 5, sorry, you have a 3, and therefore you have 2 other digits adding up to 12. So it's either 4, 8, so it'd be 3 with 4, 8, or 3 with 5, 7. Well, if the 3 were here, that would mean this has to be... Okay. If the 3 were here, that would force this to be 1, 2, 4, 6, because the 3 could not be here, and this would add up to 13. So 1, 2, 4, 6 would mean this 3 would have to be specifically with 5, 7. If it's 13 and you have to have a 5 with it, 13 minus 5 is 8. So it's either 1, 7, 5. So I think either way this has to have a 5, right? If it's 13, if it's 15, you have to have a 3 here, which means this cannot be have a 3. So the 3 has to be in the sum. So it's 13, which makes this a 2, 4, which makes this 1, 2, 4, 6. Therefore, this 3 to add up to 12 cannot be 3, 3, 9. Obviously, it can't be 3, 4, 8. It's 3, 5, 7. So I think 5 has to be here both times, which means this cannot be 5. This cannot have a 5. So it's either 1, 2, 4, 6, or 2, 3, or 1, 2, 4, 8. 1, 2, 3, 8. Right? Because 5 is always here, which means this cannot be 2, 3, 4, 5. So it's either 1, 2, 4, 6, or it's 1, 2, 3, 8. Adding up to 14. So if this is 5 and this adds up with, well, we can't have a 2. So 13 minus 5 is 8. You can't have 2, 6, so it must be 1, 5, and 7 if that's the case. So this is 7 no matter what, which means this can't be 7. This is either 3, 5, 7 or it's 1, 5, 7. This cannot then be 1, 2, 3, 8, adding up to 14. Therefore, it must be 1, 2, 4, 6, which eliminates 1, 2, 4, 6 in the rest of the row. Therefore, this can't be 1, 3, 4, or 6. This has to be a 9. So this is 9. This has to be 8. This cannot be 9. What are the possible combinations again? If it was 26, that means it had to have a 4 and an 8. So that's 12. It would have to be 5, 8, and 9. So it cannot be 26. It's 24. So it's 24 with, therefore, 6 and 8. It cannot add 1 and 9 to add to 10 to add to 24. So it has to be 3 and 7. So 6, 8, 3, 6, 7, 8 adds up to, so 9, 8, and 7 add up to 24. So the rest of column 9 is 1, 2, 4, 5. Okay. 3 digits can never add up to 1, 2, 3, or 4. That's still not helpful. 3 digits could add up to 9. Or it's 14, or it's 19. But if 3 digits add up to 9, this would have to include a 1 and a 4. So it would have to be 144. So it cannot add up to 19 here. Sorry, cannot add up to 9. Obviously, can't add up to 1 and 4 with 3 unique digits. So that doesn't work. This is 20-something. So it could be 14 or 19. If it's 14, it's 9 here with a... So 14 minus 9 is 5. So it's either 1, 4 or 2, 3. So this is either 9, 1, 4 or 2, 3 to add up to 14. If it's 19, you have to have a 4 here. So 19 minus 4 is 15. So it'd be 469 or 478. We're not sure. This is 20-something. It's either 23, 24, or 25. Because 4 unique digits must at least add up to a single two-digit number, two-digit sum. And it cannot be 30 because there's no 0 involved. So if it's 25, that would have to include 3 and 4. It's kind of broad. Oh, this is 148 here. We don't know how large it is, though. It's obviously greater than 8, so it can't be a single digit. It's either 14 or, well, it cannot be 48 because you can't omit digits, or you can't repeat digits in the FOMO cages. So it's either 14 or 18. We don't have enough information there, I don't think. So again, this is either 14, which means this is 9 and 1, 4, or 9 and 2, 3. Or this is 19, which is 4 with 6, 9, or 4 with 7, 8. Okay. If we had 25 here, we guarantee to have a 3 and a 4 here. That eliminates 4 from being here, but then that would also eliminate 19 or 14 cage with a 9 in it, right? Because then the 3 and the 4 would eliminate 1, 4, and 2, 3 as possibilities. And the 4 would obviously eliminate 4 required to be here. So this cannot be 25. It's either 24 or 23, which means the 5 does have to be one of these digits. So this can't be a 5. So it's 1 through 4, 6, 7, 8, 9 here. So it has to have a 5. If it adds up to 24, it has to have 3 and 5. 24 minus 3 and 5 is 24 minus 8, which is 16. So it would have to have, if it's 24, it would be 3, 5, 7, 9, right? So 3, 5, 7, 9 would eliminate 9 here. It would have to be 4 with 6, 9, or 7, 8, but that's not possible with the 3, 5, 7, 9 being here. Therefore, it cannot add up to 24. It must add up to 23. So this must be 4 and 5. Since this is 4 and 5, this cannot contain a 4, so this must contain a 9. So it must be 2, 3, and 9 here, which eliminates 2, 3, and 9 in the rest of the row. This can't be 4. Since this is 4 and 5, and it adds up 23 for 4 digits, it cannot have a 2, 3, or 9. 23 minus 9 is 14. It cannot have 9, so it's 4, 5, 6, 8, adding up to 23. So this would be 4, 5, and 4, 5, 6, 8. This can't be 6 or 8, so this is a 1, 7 pair. This adds up to 14 and 23. Yeah, so that's fine. This is 1 or 7. Okay, so 3 unique digits. It's either 12, 13, or 14. If it's 12, you have to have a 3 and a 4 here. If you have 14, you have to have a 2 and a 3 here, but that 2 and 3 plus this 2 digits from 2, 3, and 9 here would form 4 unique cells in box 7, which would have to have 2, 3, and 9, which are only 3 digits, so that's not possible. So this can't be 14. If we tried to have 12, we have to have 3 and 4 here, and it can't be here because this is 4, 5, 6, 8, adding up to 23. This is 2, 3, 9, adding up to 14. So if we try to have 12, you would have to have 3, 4, and 1, or 3, 4, and 7, and neither of those add up to 12. So it cannot be 12, it cannot be 14, therefore it must be 13, which means we have to have a 2 and a 4 here. Well, 2 and 4 plus 7 adds up to 13. So this is 7, this is 1. 2 obviously can't be in the same box as the 2-4 pair. This also cannot be 2 or 4. It's a 1-6 pair. So where is the 2 in row 9? It has to be here. That's a 2. This 2 is eliminated here. So 2 has to be one of these 2 digits here. Remaining digits in column 1 are 1, 3, 5, 6, 8, 9. 2 has to be here. One of these 2 digits. The remaining digits in box 7 are 1, 5, 6, and 8. Okay. This either adds up to 9 with a 1 or 2. So then it would be 1, 2, 6, but then we have 5 digits in box 1, which requires 1, 2, 4, and 6. So that can't be the case. So it cannot be 9. If it's 19, it's either 12 or 19 here. If it's 12, it has to have a 9 with a 1, 2, 1, 2 pair. And that could work with this is 9, 1, and this is 2. So that would be the case there. 9, 1, 2. To add up to 12. If it's 19, it has to have a 2 there. So it would be 2, 8, and 9. And that does work too also. So we know 9 has to be one of these digits, which means this cannot be 9. This has to be a 3, which makes this 9. This has to be a 2. This cannot be 9 here. And this can't be 2 here. So this must be a 2 here. 1, 5, 8. So if you have an 8, you can't have 3 digits adding up to 1 or 5. You could have them adding up to 8 with 1 and 5. Therefore, it would be 1, 2, 5 adding up to 8. That's possible. This would be 3, 7. This would be a 6, 8 pair. This would be 4. If you remove the 8, you would have to have 15 as the sum of the cage. 15 minus 8 is 7. So if you had 8 here, this would then be 3. This would have to be 3, 6, 7, and this would be 3, 5, 7, and that would eliminate 3, 5, 6, 7 from the rest of the box. 3, 5, 6, 7. If you have 15 minus 8, it's either 1, 6, which is eliminated by the 3, 6, 5, 6, 7 quadruple, 2, 5, or 3, 4, and that's not possible. So this cannot be 15 by removing the 8. If you remove the 5, you have 18, so this would be 5. Either way, this has to have a 5 then. So this cannot be 5. Therefore, this is a 3, 7 pair, which forces this to be 5. This cannot be a 3, 7 pair. This has to be a 6, 8 pair, which eliminates 6 and 8 in the rest of the column and the rest of the box. If this was 5 and adding up to 18, The problem is that you would have to have 18 minus 5, which would be 13. That means 4, 9, which we can't have a 9 here. 5, 8, which are both eliminated, and 6, 7, which are both eliminated. Therefore, this must be 1, 2, 5, which forces this to be a 4. So this cannot be 4 here. We have a 1, 2, 5 triplet here. Okay, we just got this one. And this is either 4 unique digits, can never add up to a sum of, what is it? Well, you can't remove the 2. Because if you remove the 2, the problem is that you would add up to 15, but this can't be 2 because of that 2. These can't be 2 because of this 2, 4 pair, and this can't be 2 because of this 2. So 2 can never appear here. 2 has to be in the sum. So it's either 12 or 25. And if it's 12, well, 4 unique digits adding up to 12, it's either 1, 2, 3, 6 or 1, 2, 4, 5, but we already showed you can't have a 2 there. Therefore, it must be 25, and we have to have a 1 here. It has to be 1 plus 7, 8, 9. So this has to be 1 and 8, which forces this, and we have a 1, 8, 1, 8, 9 triplet in column 2, which eliminates 1, 8, and 9 from the rest of the column. So this can't be 9. This has to be a 7, which forces this to be a 9. This is a 1, 8 pair. That eliminates 1 here. That eliminates 1 here. This has to be 4, 5, and 6. So 9 is, we knew already is one of those two. This is 1 or 8. This is 1 or 8. This is 9. This is 7. To add up to 25 with a 1. This cannot be 5 here. Oh, if this is 2, 8, 9, the problem is that this would be... Yeah, that doesn't work as 2, 8, 9. If it's 2, 8, 9, even though it adds up to 19, we have to use a 1. So this can't be 2, 8, 9. It has to be 1, 9, and 2, adding up to 12, because we need the 9 here. So this can't be 1. This is 6, this is 4, and this is 1. Obviously, none of these can be 6. This can't be 1, so this is 8, which makes that a 1. Uh-oh. I don't know if I did this correctly. Anyways, this can't be 1. This has to be 3, 5, 7, 8, 3, 5, 7, 8. This is 1 here. I didn't get any clearing from any other thing, which is bad. Four unique digits must add up to a 2-digit number. Again, 2 can't be any of these, because this must be a 2, 4 pair. 2 can't be here, 2 can't be here. Okay. We are kind of stuck, because I don't know... this can't be 4. This is a 5, 6 pair. This is a 5, 6 pair, that's a 5, 6 pair. This can't be 5. So 5 in row 9 has to be one of these 3 cells, which means this can't be 5. We're left with a 2, 4, 2, 4 pair in row 7. What are the remaining digits in row 7? 3, 5, 6, and 7. 5 cannot be here, though. 5 can't be here. Where is the 5 in row 7? It has to be here. So this is 5. Okay, there we go. So this is still correct. This is either 5 digits. 5 digits adds up to something that is a 2-digit number. So it's either, it can't be 12 because 5 digits adds up to at least 15. It could be 19 or 29. If it's 29, we have a 1 there. 1 would have to be in the cage. And what would be the max? 5, it would have to be, so 29 minus 1 is 28. We don't have a 7 involved. So I think it would have to be 15689, adding up to 29. Right? 15689. 8, 9 adds up to 17, plus 5 and 6 is 11, so it's 28, plus 1 is 29. So if this is 29, it's 15689. If it's 19, you have to have a 2 there, but no 3. So this would be a 2-4 pair in that case, if that were the case. 4 cannot be here, so this would be 2, this would be 4. Otherwise, you'd have... So 2 has to be one of these 2 digits here. Okay. Where is 9? 9 has to be one of these 2 digits. If you had a 2 and 4 other digits adding up to 19, you don't have a 3 or a 7. So 2 is at minimum, then you have 2, 1, 2, 4, 6. No, 1, 2, 4, 5 is minimum. That's 12. We need 7 more in value. And it couldn't be 1, 2, 4, 5 because this is 1, 2, 4, 5 here. So that would eliminate all possibilities for that cell if it were 1, 2, 4, 5, obviously. 2, so 4 digits adding up to 17 without a 3 or a 7. To 17. Without a 2, a 3, or a 7. I don't think it's possible. You have to have a 1 because 4, 5, 6, 8 adds up to 23. Right? That's 15 plus 8, which is 23, right? So you have to have a 1. But what are the combinations of 1 with another digit that does not have a 7 that can add up to 17 without a 2 or 3? 145 would require a 7. 146 would be with a 6, which is not possible. 156 requires a 5 to add up to 17. Yeah, so this has to be 15689 then to add up to 29. And this can't be, this is a 2-4 pair, but this can't be 4 because of this 4. So this is 2, this is 4, this is 2, which makes this 1, this is 5. So 5 cannot be either of these. This 2 eliminates 2 here. This is 4 unique digits, which means it adds up to a 2-digit number. So it's either 25 or 27. If it's 25, it has a 7 in it. If it's 27, it has a 5 in it. Hmm. 2 must be one of these 2 digits. So if it's 27 minus 5, it would have to be with 6, 7, and 9. So either way, it requires a 7, right? So if you have 7 removed from the sum, you have 20, it add up to the cage adding up to 25, and the 7 being in the cage. Well, 7 can't be here. 7 would have to be here in the cage. If it's 27, you have to have a 5 in the cage, but the rest of the 3 digits must add up to 22, which is 27 minus 5. And therefore, it would have to be 589, which we already have a 5, or 679, which would require a 7. So either way, you require a 7. So this is 7, which means this cannot be 7. This is 3 and 6. That eliminates 3 and 6 in the rest of the box. This can't be 6. This is 8. This can't be 6 or 8. So this is 4. That requires this to be 6. So this has to be then a 7-9 pair here. Oops. A 7-9 pair. That leaves this as a 3-4-8 pair. This can't be 8 because of the 8 in the column. Let's So this either so it's these three digits either add up to 20 with a 5, so it would be 569, or it's 18 and there's no restriction. Okay. If it's 18, it could be 189, 369. 3 cannot have a 7. So this is either 5, 6, and 9, which would mean this is not 9, this is not 5, this is not 5 or 6. So 9 would be here, this would be 6, this would be 5. To add up to 27. Because there's no 7 here. If it adds up to 18, it could be 189. So this would be 8 with 1 and 9. It'd be 18 because we have to have a 7, but we already have a 7 in the cage. 189. That's the only one with 3 digits. Add up to 18. 3 can be 369 or 378, but there's no 7 involved, so this would be 3, 6, and 9. So this would be 3 or 6. This would be 3, 6, or 9. This would be 3 or 9. You can't have 4. 5 would only be 5, 6, and 7, and we don't have a 5. So this has to be, I think this has to be guaranteed to be 9 then. Which means 9 cannot be here, and 9 cannot be here. This is 4 digits. This also adds up to 11. Sorry, it adds up to at least a 2-digit number. It cannot have a 2 in this, so it's 4 digits adding up to either 14 or 15. 14 with a 5. So if it's 14 with a 5, that would be 14 minus 5. The other 3 digits would have to add up to 9. 14 minus 5 is 9. And without a 5, because you already have the 5 in the cage, it would be either 1, 2, 6 or 2, 3, 4. But we know neither of these, well, this can't be 2 and this can't be 2. So you cannot have a 2 in this cage. So it cannot be 14 adding up to a 5. So we need a 4 here adding up to 15. That means the other 3 digits without a 2 must add up to 15 minus 4, which is 11. Without a 2, you can't have 1, 2, 8, so you could be 1, 3, 7 is possible. No 2. So you have to have a 1. So 1 cannot be any of these cells, so this must be a 1 here. So this is 1. We have 1 and 4 adding up to 5. The other 2 digits must add up to 10. It cannot be 4, 6, 1, 9, or 2, 8. It has to be 3, 7. So this must be 3, 4, and 7 here. And since we have a 3, 4, 7 triplet in row 4, that eliminates 3, 4, and 7 in the rest of the row. So this can't be 1 or 3. This can't be 1. 4 has to be one of these 2 digits, which means this can't be 4. This 1 eliminates 1, 8, and 9 as a possibility. So it's either 5, 6, 9 adding up to... This can't be 8. It's either 5, 6, 9 here adding up to 20, or 3, 6, 9 adding up to 18. So 6 and 9 both have to be here, which means this can't be 6. So we know 6 has to be one of these 2. 3, 4, 7 all see this cell, so this can't be 3. So this is 5 or 6 here. This cannot be 3, 4, or 7. Can't be 1, can't be 6 or 9. So it can't be 1, 2, 3, 4. It could be 5. It can't be 6. It can't be 7. It could be 8. So this is 5 or 8. Interesting. 1 cannot be here. 1 has to be one of these two digits here. This is a 1-9 pair. If this were 14 with an 8, it has to be 2, 4, 8. So that is possible. If this is 18 with a 4, that doesn't work. Well, okay, so you could actually have the cage go here. So that's not an impossibility. If it's that case, if this is 18, that means 3 digits adding up to 10. You can't have 4 digits because that would be 1, 2, 3, 4. And there's no possibility here for that. Right, because 1 would not be valid in any of these boxes. If you tried to have 3 digits without a 1 adding up to 10 would be 2, 3, and 5, but we have a 5 in that box, so that doesn't work. So this must be 2 digits adding up to 10, but it has to have a 4 in it, right? So 4 would be 4, 8, and 6. So either way, this is a 4 here. So we know this is 4. This cannot be 4, so this must be a 4 here. This can't be 4, this must be 3. That eliminates 3 and 4 here, so this is 8, this is 4. This can't be a 3. We know this is a 6. 3 eliminates 3 here, so this is 7, which makes this 3, which makes that 7. 7 eliminates 7 here, so this is 3. These cannot be 3 anymore. This must be 2, 6, or 9, but it cannot be 6 or 9 because 6 or 9 has to be here. So this must be 2, which makes this a 6. That means this can't be 2. This is 9. This 9 must have, it eliminates 9 here. So this is 3. This is 6. This becomes a 5, 8 pair. This can't be 5 because it's 5 in the column. So this is 8, which makes this 5. That eliminates 5 here. So this is 6, which eliminates 6 here. So it's 5. That's 6. This can't be 5, 6, or 8. This becomes a 1, 9 pair, which eliminates 1 and 9 in the rest of the box. This can't be 1. This can't be 9. This has to have a 6 here. This 1, 9 pair eliminates 1 and 9 in the rest of the row. Where's the 1 in column 1? It has to be here. Where's the 9 in column 1? It has to be here, because this can't be 9. This can't be 9 anymore. This can't be 5 or 8, so this must be 3. This 3 eliminates 3 here. This becomes a 5, 8 pair in box 1, which eliminates 5 and 8 in the rest of box 1. So this is 7. This is 3. This 6 eliminates 6 here, so it's 8, 6. 8 eliminates 8 here. It's 5 and 8. 5 eliminates 5 here. So this cannot be 5. This has to be a 4 because that's the only remaining digit there. We have 5 and 8 remaining in column. Wait, this is not a 1 because that's not correct. That's bad. Oh no, this could be 1, 8. Okay, so this stuff is still incorrect. Okay, my apologies for that. I think everything else still flows correctly though. This is just a 1, 8 pair. This could be 2, 8, 9 to add up to, because the 2 is the one that has to be there. So this is still, okay. I don't think anything else was affected by that, but yeah, this is incorrect. This is, dang it. Okay. So we don't know if this is a 1. This is all off 2. So we don't know about this one. Ooh, this part. Okay. Oof. That's bad. That's really bad. Okay, we have to go back there. I don't know if the logic actually follows. Then this part specifically worked because we knew this couldn't be part of the cage. But we don't know actually that because this was actually I had this correct before with this being 289 instead of the 1 being there. I don't know why. I just messed that up. Okay, let's go back. Apologies for that. Sometimes I get a little ahead of myself. Okay. Um, we still have that. Okay. That is still correct. We don't know about the 4. We don't know about this. This can't be 1. Right, we were looking at this. This can't be 5, so this still has to be a 5 here, which means this cannot be a 5. Right, so this is still 2 4 2 4 pair, which means this is still 3 5 6 7. This can't be 5. Ooh, I don't even remember what I did here. Uh, this could be 1 4. That's bad still. Oh, these can't be 5. Okay, so that still works. Therefore, this is a 5 here. Okay, that still works. This is still the same, so this has to be 1 5 6 8 9 because we tried removing the 2 from the sum and then adding up to 19 without a 3, 2, or 7. Or actually, a 2 guaranteed here and without a 3 or 7, and that doesn't work. So this is 1 5 6 8 9, which forces this to become a 2 4 pair. This can't be 4, so this is 2, this is 4, this is 2, this is 1, this is 5. This is all the same logic. This can't be 5 here. This requires a 7 in this cage, so this would have to be 7 there, which means this can't be 7. This is a 3 6 pair. That eliminates 3 and 6 here. This can't be 6. This is 8. This is 6. This becomes a 7 9 pair. 8 cannot be either of these because of this 8. This has to be 3, 4, and 8 here. 8 cannot be here. Again, we have the same logic here. None of these can be 2 because 2 cannot be here and 2 cannot be here. So this is still the same logic. It has to have a 1. Ooh, but 1 could be here. Shoot. Okay, so this is still 5, 6, 9 as possibilities, and this can't be 9, this can't be 5, this can't be 5 or 6, so this would be 9, 6, and 5. It could be 1, 8, 9. This would be 9, and this would be 1, 8, and 1, 8. Or you have 3, 4, no, 3, 6, 9. Adding up to 18. And this would be 3 or 6. This would be 3, 6, or 9. This would be 3 or 9. Either way, 9 does have to be one of these 2 digits. We don't know about 6, though. Okay. This, again, you can't have a 2 here or here, so this does not include a 2. If we try to remove the 5 and add it up to 14, that means 3 digits adding up to 9 without a 5, which would be 1 2 6 or 2 3 4, and we know that those can't be the case, so 4 has to be here. I think it had to be 4, then the 3 digits adding up without a 2 to 11. It has to have a 1. So 1 has to be one of these 3. 4 has to be one of these 3. You can't have 2 here, so no 2 8 adding up to 10. No 1 9 because we already have a 1. No 4 6. This has to be 3 7. So then we know this is 1 3 4 7. Okay. We know 1 and 4 have to be here because of the 1, 3, 4, 7 quadruplet in row 4. So this can't be 1, this can't be 1 or 3, this becomes 5, 6, 8, 9, but it can't be 9 because of that 9. This is 1, 3, 4, 7 here. This can't be 1 or 4 because this has to be 1 or 4 here. So this logic, not necessarily kosher. We don't know. This is 1, 3, 4, 7. So they both see these two digits here. So this cannot be 1, 3, 4, or 7. No 1, 2, 3, 4, 7. It could be 5, 6, or 8 here. Okay. 1 and 4 both have to be here. This can no longer be 1, so this can't be 8. This has to be 6 then here. So this is still the same. This is the same logic. We can't get this logic necessarily. Because it could be two unique digits. It could be one, well, 1 we are not guaranteed to be here. 2 has to be one of these two digits. It cannot be 1 and 4. So this 7 eliminates 7 here. So no 1, 4. It could be 2, 3, 5, 6, 8, and 9, and 7. But 6 and 9 are not possible because we know 6 and 9 are here, so this can't be 6 or 9. 2, 1. Okay, so 2 is here. Right. This obviously cannot be 1. So 1 is one of these two. No 9, no 6 here. This can't be 9 or 6, so it's 1, 3, 5, 8 also. This can't be 8 because of the 8 in the column. One of these two is an 8, though. Because 8 can no longer be here. It would have to be 8, 9, and 1. Otherwise, it just doesn't fit. So 8 cannot be here. 8 cannot be here. We know 2's here, so that's not helpful. This could be 1, 2, 3, 4, adding up to 10. What about 3 digits adding up to 10? So again, you can't, if it's adding up to 14, you have to have 8. I guess it could be 2, 3, and 1 even also though. So you're not guaranteed a 4 here. It would be 2, 3, and then this would be okay. So what are the remaining digits in column 5? Well, you could have 2, 3, 4, 6, 7, or 9. 4 can't be here. Can 9 ever be either of these? No, because that would guarantee this would have to be 18, but we need a 4 there. And 4, 8, and 9 already add up to 21. So 9 cannot be either of these. Where is the 9 in column 5? It has to be here. So this is a 9. That forces us to be 3 and 6 to add up to 18. These can't be 3. This is a 1, 4, 7 triplet, which eliminates 1, 4, and 7 in the rest of the cage. So this is 3. This can't be 3 then. There's no 3 here. This can't be 7, so this is a 3, which makes this 7. None of these can be 7. It cannot have a 3 either. This is a 2, 5, 8 triplet, which eliminates 2, 5, and 8 for the rest of the row. This can't be 5. And this can't be 5. So we have a 4. This can't be 5. We have a 4, 6, 4, 6 pair in column 2, which eliminates 4 and 6 in the rest of the column. This is 5. This is 6. This can't be 6 anymore. This can't be 3. This can't be 3. 3 is either here or here. This cannot be 1, 2, 3 anymore, adding up to 14. Where is the 3, actually? This 5 eliminates 5 here, so this is 2. which means this can't be 2 here. This 2 eliminates 2 here and here. This becomes a 4, 6, 7 triplet possibility, which eliminates 4, 6, and 7 in the rest of the column. This is 3 then. This can't be 3. This can't be 3. And to add up to 14 or 18, you can only add up to 18. So this must be 4 and 6. So there we go. This is 4 and 6. That leaves us a 7. This can't be 7. This is a 1-4 pair here. This can't be 6. So the 6 has to be one of these 2 digits here, which means this cannot be 6. 4 eliminates 4 here, so this must be 1, which makes this 4, which makes that 1. So then we get that again. So this is 8, this is 4. This 8 eliminates 8 here, so this is 5 and 8. That must be 7 here then. This is 2 and 9. 7 cannot be here, here, or here, so 7 must be here. This 1 eliminates 1 here, so this is 6, this is 4, this becomes 6. This can't be 6 anymore here. This can't be 6, becomes a 1-9 pair, which eliminates 1 and 9 in the rest of the box and the rest of the row. This can't be 1 or 9, so this must be 3. So it's very similar here. This can't be 3. Of the digits remaining, where is the 3 in box 1? It has to be here. So this is 3. This has to be a 4, because that's the only digit remaining. We have a 1, 5, 8 triplet in box 4, which eliminates 1, 5, and 8 in the rest of the box. So this is 9. So that's all the same. This 4 eliminates 4 here, so that's 2 and 4 here. This is 4 digits with a 4 and a 7, so that's already 11. 4 digits can only add up to, out of the possibilities, it cannot be 47, it cannot be 14, so it has to be 17 here. So this would be 4 and 7, 11. So it's 1 and 5 here. So this has to be 1, and this is 5, which makes this an 8. This 1 eliminates 1 here, so that's 8, 1. These can't be 1, so again, the previous mess up, that fixes that. This 8 eliminates 8 here, so this is 5, which means this can't be 5. This is 6, this has to be 8. This 5 eliminates 5 here, so this has to be 5 here. This has to be a 1-2 pair here. This 1-2 pair eliminates 1 here, so this is 9, this is 1, that makes this 7, which makes that 9. 7 eliminates 7 here, it's 3 and 7. That eliminates 3 here, so this is 6 and 3. The 6 here eliminates 6 here, so it's 8 and 6. 8 eliminates 8 here, so it's 9 and 8. That eliminates 9 here, 2 and 9, which makes this 1 and 2, which makes this 5 and 1. Okay. Apologies for that quick mistake there. I actually had the logic correct. I just didn't. I messed up when I was thinking things through. So I had this logic correct, but I messed up. And it showed later on, so that's fine. At least we were able to backtrack and find it and fix the problem. Anyways, yeah. Without that mistake, it would have been pretty straightforward. I'm not sure if I like this. It's a lot of math. And I don't know. It's interesting. But at the same time, I don't know how much I enjoyed it. Anyways, I hope you enjoyed this solve, though. And I'll see you next time on Frank Puzzles. Take care.